All right, let's jump into notes 2. So it's going to be pretty straightforward. I'm going to have you answer a question, and then we'll pause the video, and then you will answer it. And then once you're done, then we'll resume the video and talk about them. So number 1, I want you to answer A and B. These are not looking up. These are just on your own. Why does a giant barge float in water, but a small rock does not? And if you stand on a scale in the water, why will you notice that it says you're way less than if you stand on the same scale on land? Take about 3 to 4 minutes and answer those 2 questions for me. Pause the video now. Okay, we'll go over those answers a little bit later, so let's jump into 2 and 3. I want you to go ahead and do 2 and 3 on your own now, and you can use your book to answer them. The books are in the back of the room. You're going to do page 249. And this chunk right here on buoyancy. This should be all you need, this section here. The pictures may be helpful as well. But go ahead and answer 2 and 3. Take about 5 minutes to do that. Go ahead and pause the video again. Number 2, what is buoyant force and what is its cause? It's a support force that for objects that are in a fluid. And it's caused by a pressure difference from the displaced fluid. Okay, so when you have an object inside of a fluid, what happens is that there's a force because the object is taking up space. The water would like to be in here. The water would like to be in this space. So it pushes in on the object from all sides because it wants to get in that space. Now, the thing is, because what we talked about last time, that the pressure changes depending on depth, that means that the pressure on the bottom is going to be a little bit more than the pressure on the top will be. And that means that the overall net force is going to push the object up. And that's where the support force comes from. So that's what the buoyant force is. So what does volume of displaced fluid, and what does it mean, and what does it equal? So volume of displaced fluid is the cubic meters. It's the amount of fluid displaced by the object. So what does it equal? So the volume of the displaced fluid equals the volume of the submerged object. Now, the submerged object may not be the entirety of it. So if it's not the whole object, it's just how much is submerged. But the volume of the fluid that's displaced is equal to the volume of the object. So if you have a 3 cubic meter box and you submerge the whole thing in water, then the displaced fluid is 3 cubic meters of fluid. So a wood cube that floats on a tub of water. So what would the forces be on this cube? So we're going to be doing Newton's laws here. And so you're going to do a free body diagram. So here's my wood cube that looks a lot more like a rectangle. And that is made up of a couple of forces. There is a force of gravity pulling down and the buoyant force pushing up. So if I was going to set this up, F net equals ma, that's Newton's second law. So the upward force is the buoyant force minus the downward force, which is gravity, equals the net force of 0 because it's floating. So there's no upward motion, no downward motion, there's no acceleration. In other words, the buoyant force equals the force of gravity for objects that float, which makes sense. The object should float if the buoyant force equals the weight. If the buoyant force is larger than the weight, the object will rise to the surface, but that's only going to happen if it's submerged all the way. it'll never get launched out of the water. And then the force of gravity is larger, then it's going to sink. So if the volume of the object is 10 cubic meters and half of it is submerged, what's the volume of the displaced fluid? So the volume of the submerged object equals volume of the displaced fluid. So if we displace half of 10 cubic meters because of the object's size, then we would displace half of that amount. So there you go, 5 cubic meters. Okay, I want you to go ahead now and do number 5. Take about 3 minutes or so to talk about Archimedes Principle. So Archimedes Principle got its own little section here. Go ahead and do that part. Talk about what Archimedes Principle is. Go ahead and pause the video. Okay. So Archimedes' principle is pretty straightforward, even if it is a little strange. So it says the buoyant force equals the weight of the displaced fluid. So remember, weight is a force. So basically, the buoyant force equals the force of gravity on the fluid that's displaced. So however much fluid is displaced, figure out the weight of that fluid, and that's the buoyant force. The equation he came up with is mass of the fluid times gravity. Now, there's a lot of things you can do with this. You can do pressure, you could do density, you can set it up with a lot of different things. But we're going to use a shortcut equation that will help us with some of the more complex problems. And that shortcut equation is this. Now, it's going to look kind of nasty. But it's going to make solving a lot easier. So what do all these things mean? So FB is buoyant force. I feel like that one's pretty straightforward. G is the acceleration of gravity, 9.8. M is the mass of the fluid. And O is object. So MF is mass of the fluid. G is 9.8, acceleration due to gravity. FB is buoyant force. Rho F, so that funky P. F is the density of the fluid. Mass of the object divided by the density of the object times G. So there's Archimedes' principle. And for a side fact, this is the thing that made him say Eureka. So he screamed Eureka when he figured this out because apparently he was super pumped by buoyant forces. Anyway, maybe just like boats. So I want you to go ahead and do the next several here. So explain how buoyant force on a block is different if it's partially submerged or fully submerged. Explain how a 50 Newton object could feel like a 30 Newton object. Why does buoyant force not depend on depth? And then what property most affects whether an object sinks or floats? Okay, go ahead and take some time to do those. That's going to take you a little bit longer here. And make sure you're doing these on your own. I know it's tempting to just wait for me to go over them, but do them on your own. Trust me, you'll want to do that. Okay, take about 5 to 10 minutes, depending about how long it takes you to get through those ones there. And these ones in particular, the pictures will be helpful, particularly this one will help a lot when you're doing number 8. Why does buoyant force not depend on depth? This will help a lot with that, so if you're having trouble with that one. Okay, pause the video and go ahead and answer those. All right, in order to save a little bit of time and to keep you honest, I'm not going to go over these. Now, if you would like to check your answers, I will post a key next class, not today. You got to do these on your own. Make sure you're following along. I do want to talk about one of these here. So, why does the buoyant force not depend on depth? So this picture is a really good example of that. And the pressure is always lower under an object as it is above. But as we go down, it increases linearly, which means that the downward pushing up increases at the same rate as the upward pushing down. So if this is one arrow up more than the arrow down, then when we go a little further, it's still one more arrow up than down. It's still one more arrow up than down. So no matter where I am, it's the same force distribution, the same pressure distribution, which means the buoyant force does not change with depth, even though the pressure does. So the pressure will change, but the buoyant force will not. That's a really key one for number 8 there. All right, let's go ahead and talk about 10, because I find this one kind of confusing for people. So 3 rules about sinking and floating. So number 9, we'll do number 9. What property most affects whether it sinks or floats? That is the density of the object. In general, objects that are less dense than the fluid will float. Objects that are as dense as the fluid will neither sink nor float. They'll just stay wherever they are. I know that sounds weird, but that's what fish do. If you've ever wondered how fish just chill in the middle of the fish tank, right? So if they got like a ocean here and you got your little fish. Have you ever wondered how some fish can just like chill in one spot? Well, the reason they can chill in one spot is because they are able to keep their density equal to water. And if they keep their density equal to water, then they just stay where they are. And objects that are more dense than the fluid will sink. Okay. Number 11, how is it that something that's really dense like iron can be made to float? So increasing its volume will decrease its density. You could make a rock float in water if you gave the rock enough volume. If you had enough volume in the rock, then you could actually make it float. And there are some rocks like this that'll happen. Sometimes they have rocks that are hollow in the middle, and they are able to float in the water. And so it has to have a larger volume. That'll decrease its density, and it'll make it so it can float. So anything can float if you change the density. Okay, that's why humans can float if you inhale a lot of air and hold your breath for a little bit. You can float because you lower your density by increasing the volume, having more air in your lungs. Okay, principle of flotation. So the principle of flotation is just this. Force, buoyant force equals the force of gravity. We talked about that earlier. That's only for floating. But that is the principle of flotation. And I'm going to have you do 13 on your own. How does density of the fluid affect flotation? So if you have a fluid that's more dense or less dense, does that mean more objects will float, more objects will sink? Go ahead and either think of that one on your own, or you can look that one up in the reading. Okay, we're going to go ahead and do the example problems, but I'm going to do that on a separate video, so go ahead and go to the back side.